S. Chan presents educational video lectures. Difficult concepts made easy. Study anywhere, anytime.
Dear students, welcome to S. Chand Academy. I am Sameer Kumar. We have learned Poisson's distribution, right? The formula for the Poisson's distribution, how is the distribution, and everything we have seen how we have arrived at the formula starting from the binomial distribution, right? But until and unless it is useful for us, we know how to use it in our real life scenario, it doesn't make much sense, right? So we'll see an example of how the distribution can be useful. Okay.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box.
Records show that the probability is 0.0005 that a car will have a flat tire while crossing a certain bridge. Use the Poisson's distribution to approximate the binomial probabilities that among 10,000 cars crossing this bridge, exactly 2 will have a flat tire. Okay. So a scenario like this can be useful in the case of army. Okay. Suppose an army is going to cross to is marching and it has to cross a bridge, right? And then you have to take stock or maintain the inventory and the supplies and other things, like how many vehicles and other things you have to maintain in the inventory, and what are the chances of the vehicles going into breakdown. They are no more useful, so you have to keep some buffer number of vehicles and other things in stock, so as whenever there is a need we can use them, okay, under such situations, right? So this gives a similar scenario, right? Suppose there are 10,000 cars crossing a bridge. The probability of getting a flat tire crossing a bridge is obviously very low, right? Is 0.0005% that a car will get a flat tire. Okay. So using the Poisson's distribution, what is the probability that out of the 10,000 cars, exactly 2 cars will go flat? Okay. Right. So first, we know that probability x for the Poisson's distribution is given by e to the power minus lambda, lambda to the power x upon x factorial, right? X factorial. This is the probability, okay? For x exactly equal to 2, I'll plug x is equal to 2, okay? So p x equals 2 is, I have to estimate the value of lambda also. What is the value of lambda in this case? Lambda I know is n times p, right? What is n here? It is this number 10,000, okay? So that is 10,000. And what is the probability of one car going flat? This 0.00005, okay? So this is 0.5, okay? That is the value of lambda for this case here. The value of lambda is 0.5, okay? I need that what is the probability of exactly 2 cars going flat tire. I'll plug lambda is equal to 0.5 and x as 2 e to the power negative 0.5 upon 2 factorial. Okay, right. So obviously again you have to use calculator to find this out. So this value when you find out comes out to be 0.076 or 58 if I write exactly. This is p x equals 2. Okay. 0.0758 is the probability that exactly 2 cars out of the 10,000 cars crossing the bridge will get a flat tire. Okay. So now you see what is this table? What is this table? Because we have to do these calculations every time to avoid that, okay, because every time you may be asked that, okay, what are the chances that 15 or lesser number of cars go flat tire? So then you'll have to find out for everyone what is the probability of getting one car, two car, three car, four car until 15 cars. All these numbers you'll have to find out, then add them up. Okay, so that is going to be some calculation. It is going to take some time to calculate, but so we have tabulated everything for our convenience, okay, so that we don't have to do these calculations every time. So if you look at the table carefully, you'll find this number already there, okay. So for lambda equal to 0.5, and what is x? X was 2. For 2 here, if you see 0.0758, okay, this number is already tabulated there, it's already there, right? So I could have simply looked in for x is equal to 2 and lambda is equal to 0.5. I'll reach to this number. I can avoid doing the calculation, okay. That is the point of the table, okay. And this table will use for the part B question here also to demonstrate how, okay, right. Now coming to the part B again, at most two will have a flat tire, okay. That means x can be 0 also, no tire, no cars going flat tire. X can be 1 also, or x can be 2 also. So I need the probability for this plus the probability of one car going flat tire plus the probability of two car going is the final probability I need, okay. If you want, you can use the same formula that we used in the first part to get the required probability, or we can simply refer the table here, okay. Lambda again we know is how much? 0.5, okay. That is this number times this number, that is lambda 0.5, right. So for x is equal to 0, and obviously this is the column we are going to refer because the value of lambda is 0.5 here. So this number as per the table is this 0.6065, okay. For x is equal to 1, this number is this 0.3033, okay. And for 2, it is 0.0758. 0758, okay. The total probability is the sum of these three numbers, okay. So yes, if I sum them up, this comes out to be 0.9856 or 98.56%, okay. Now you see the information that I have received, I have obtained by the calculation. There is a 98.56% chance, almost 99% chance that at most two cars will go flat tire, okay. At most two cars will go out of service. There is a 99% chance for that, okay. So as administrator, how many cars should I maintain in the inventory, okay, in buffer? Two cars, okay. I'll just maintain two cars as a emergency supply, as a buffer number of cars. If the cars go flat tire, I can use those two cars. There's a 99% chance, that is a fair amount, okay. So this is how we never know 100%. We cannot say anything that this is going to happen 100% always, okay. There's always a chance for everything. There's always a probability involved in everything, okay. And 99%, 98% probability, it's a very high probability, and things happening with this probability is fairly high, okay. So you see how the information, this technique can be useful in our real life scenario as well, right. I told you the use of table, the use of formula, and everything about the Poisson's distribution, okay. We'll see one more example on this one, okay, on the use of Poisson's distribution to make things clearer. Okay.
Now, quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Dear students, welcome to S. Chand Academy. I am Sameer Kumar. We are learning probability in statistics, how it can be used in our real life, and what is the purpose, because we don't want to make it like a rote learning and just learning the formula and everything and not knowing where to use, when to use, and how it can be helpful for us. Okay, so I am trying to tell you everything, like how you can use as a tool in your real life scenario also, and take benefit out of the knowledge that you have, right? Because you learn something to use it somewhere, right? We were seeing Poisson's distribution, okay, and how it can help us manage real life scenario, estimate the probabilities of different events and things happening. Okay, so we have a similar example here, that an average number of trucks arriving on any day at a truck depot in a certain city is known to be 12. What is the probability that on a given day fewer than 9 trucks will arrive at this depot, right? So this scenario is similar to like what we face in real life also. Suppose you must be getting, telemarketing calls every day. Okay, telemarketing calls every day you get. So suppose, on an average you get, let's say, 5 telemarketing calls from different companies. Take loan, take this, take insurance. So maybe on an average you get 5 telemarketing calls every day, okay, in the span of 24 hours. Okay, and suppose you have to go for an important meeting that will last for 1 hour, let's say 3 p.m. to 4 p.m. your important meeting is going to last. Okay, and you have to keep your mobile phone on also. You have to take some information, you have to search internet during the meeting. So you just cannot turn off your mobile or put it in silent. You need to hear the audio and everything. Okay, so that possibility for you is not there to turn off the mobile, and still you're worried that, okay, you don't want to receive the telemarketing call during that hour of your important meeting, right? So you want to make an estimate that, okay, on an average I get 5 telemarketing calls from different companies during the whole day, okay, like in the span of 12 hours. Then what is the probability that you'll get a call in that 3 to 4 hour, 3 p.m. to 4 p.m. time, let's say. Okay, so such estimations you can do using Poisson's distribution. Okay, here is an example, here is a similar example. Okay, the question says that the average number of trucks arriving on any day is 12. Okay, so that is the average number, that is the 5 telemarketing call that you are getting every day. So here 12 number of trucks it arrives every day on an average. Okay, so this becomes my lambda value, 12. Okay, the average mean value, 12 trucks arrive in the depot on an average. Okay, on a particular day, okay, what is the probability that you'll get fewer than 9 trucks? Okay, on a particular day, what is the probability that less than 9 trucks will arrive in the depot? Okay, so that means there can be no truck arriving, or maybe 1 truck arriving, 2 truck, 3, 4, 5, 6, 7, 8. Okay, all these possibilities, if it is there, I will say that fewer than 9 trucks have arrived. Okay, so one way to approach, of course, the probability for x we know is lambda to the power x e to the power negative lambda upon x factorial. Okay, so you plug the values for x is equal to 0, 1, 2, 3, 4, 5, 6, 7 and 8. For all these values you can plug it in the formula here. Okay, find out the value, and then add them up. Okay, and then add them up. So the probability that I required, if I write it mathematically, is going to be this: sigma probability of x is equal to I. Okay, I starts from 0 to I is equal to 8, right? So if I write the scenario mathematically, this is what you have to get, right? Sigma p x is equal to I starts from 0, ends to 8, ends until 8, and a particular probability you will get using this formula. Okay, but in probability and statistics, this chapter, we have to deal with a lot of numbers. Okay, we have to deal with a lot of numbers of various size. The numbers can be very small, the numbers can be very large also. Okay, so we try to simplify our life, ease our life. Okay, we try to tabulate the repetitive things. Okay, the repetitive things that come again, they surface over and over again. We try to set standards. Okay, so we have set a table for ourselves. Okay, and we use the table to get the values instead of doing the calculation actually, right? For example, for x is equal to 1, x is equal to 0, lambda is 12, so we'll have to look in this column. Okay, this is the column of 12, right? For x is equal to 0, the value is 0. So almost there is no chance of no truck arriving. Okay, almost there is no chance. If 12 trucks arrive on an average, there's almost no chance that no truck will arrive. Okay, until special circumstances are there, of course. Okay, the probability of one truck arriving is this, that is for x is equal to 1. Probability of two truck arriving on a particular day is this, for 2. 3 is this, 4 is this, 5 trucks arriving this, 6 trucks, 7 trucks, 8 trucks. Okay, all these values are favorable. Okay, this is what I want. So basically I will sum all these numbers to get the probability that I need here. Okay, so I'll sum these numbers up again. So this is going to be, this comes out to be 0.155. Okay, 0.155, or that is 15.5%. Okay, that is 15.5%. So I know that there is approximately 15.5, or you can say almost 16% or 15%. This is the chance that trucks lesser, fewer than 9 trucks will arrive. Okay, that is the chance of that happening, given that on an average 12 trucks arrive on a given day, right? So if suppose you are a businessman and you have to ship your goods, you are waiting at the depot for the trucks, and you have goods worth, let's say, 10 trucks. Okay, your goods will fit in 10 trucks or 9 trucks. Okay, then you can try to estimate that, okay, what is the probability that you have to wait for the other day, what is the probability that you'll have to wait for the other day. So you'll try to estimate that, okay, what are the chances that trucks lesser than 9 is going to come at the depot, right? Because you have goods that can fit only in 9 trucks or more. Okay, you have so much goods with you, you are a businessman, your goods can fit in trucks, in 9 trucks or more trucks. Okay, so you are trying to calculate chances for yourself that, okay, what is the chance that I have to wait for other day, shall I book a hotel for myself because I'll have to wait for next day also, right? So 15.5% chance is that trucks fewer than 9 is going to come. That means almost 85% chance is that, almost 85% chance is that 9 or more trucks are going to come. Okay, so 85% chance is that you don't have to book a hotel for the night, you will be leaving today only from the city, right? But there is a 15% chance, of course, that you'll have to stay the night in the same city. Okay, right? So this is how things can be useful, this information, this calculation can be useful for us in real life scenario. That is the most important part of learning mathematics, of course, right? Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.